All right, let's dive into a really nasty problem in distributed systems. It's a silent killer that can corrupt your data without you even knowing it's happening. It all starts when the one thing you rely on for safety, well, it lies to you. It's a subtle but absolutely critical failure, so let's break down exactly how this nightmare unfolds. So, just think about that for a second. You've got this distributed lock to make sure only one process can touch a critical piece of data at a time, right? You get the lock, you do your thing, you release it. Seems simple enough. But what happens when your client thinks it has the lock, but in reality, it lost it ages ago? And this is where we get into what I like to call the distributed lock nightmare. It's a classic, totally catastrophic failure that you see in systems using things like Zookeeper or etcd. And the whole thing kicks off with something totally normal, something as simple as a pause. Okay, so let's walk through the crime scene. Step 1. Client A grabs a lock from Zookeeper. Everything's going great. But then, bam, a massive garbage collection pause hits and Client A just freezes in time. Now, from Zookeeper's point of view, Client A is gone. It missed its heartbeat. So Zookeeper does its job, it expires the session and gives the lock to someone else. And that someone is Client B, who happily comes along, acquires the now available lock, and writes its data. But here comes the horror movie moment. Client A finally wakes up. It has no idea it was asleep for so long. It looks around, thinks, yep, still got my lock, and proceeds to write its data, completely blowing away everything Client B just did. And just like that, you've got data corruption. This whole disaster really shines a spotlight on a fundamental rule of distributed systems. And it all boils down to one simple fact. You can't trust the client. Ever. You know, it's tempting to blame Zookeeper for this, but the lock service did everything right. The real problem is that any client can just pause at any moment. Garbage collection, a network hiccup, the operating system getting busy, you name it. And that means a client's own internal idea of whether it holds a lock is completely and utterly unreliable. And that leads us to the heart of the matter. This quote says it all. A client can never know if it still holds the lock at the exact moment it writes. Think about it. In that tiny gap between the client checking its status and actually writing to the database, the world could have changed. Trusting the client's perspective is just asking for trouble. So, if we can't trust the client, what do? We need a final judge, an undeniable source of truth that can just cut through all this confusion. And that brings us to the solution, our hero in this story, which I think of as the sword of truth. The official name for this hero is a fencing token, and it's a beautifully simple idea. Every single time the lock service, like Zookeeper, hands out a lock, it also hands out a number, and this number only ever goes up. Think of it like taking a ticket at the deli counter. Every new customer gets a higher number. Simple, right? So how does this little numbered ticket prevent our data-destroying nightmare? Well, let's rewind and play that exact same scenario again, but this time with fencing tokens on our side. Okay, round 2. Client A gets the lock, and Zookeeper hands it token number 33. Then, of course, it freezes thanks to that pesky GC pause, and its lock expires. Along comes Client B. It gets the lock, and it's issued the next token in the sequence, number 34. Client B does its work, but when it writes to the database, it includes its token, number 34, with the request. And finally, our sleepy Client A wakes up. It tries to write its data, presenting its old, stale token, number 33. And here is where the magic happens. The database itself acts as our judge. It gets the right request from Client A with token 33. It takes one look and says, whoa, hold on. I've already processed a write with a newer token, number 34. This request is old news, and it rejects the write. Client B's write, of course, was accepted because its token was the latest and greatest. The nightmare's over. Problem solved. So if you take only one thing away from this, let it be this. The resource you are trying to protect, your database, your storage service, whatever, that is what must check the token. The whole system is useless otherwise. You can never, ever, ever trust the client to check its own status. The check has to happen at the final destination. Now, let's be real for a second. Setting up Zookeeper and implementing fencing tokens, that's a heavy lift. It's powerful, for sure, but it's a lot of operational work. So what if there's an easier way? At least for some use cases. Well, that brings us to a really pragmatic alternative. Before you go and spin up an entire Zookeeper cluster, you should really take a look at what your database might already be able to do for you. If you're using Postgres, for example, there's this fantastic feature called advisory locks. These are basically application-level locks that live right inside your database and require zero new infrastructure to manage. So let's just break down the pros and cons here. The pros are huge. First, they're transactional. If your database transaction rolls back, the lock is automatically released. It's clean. Second, it's zero offs. No new servers, no new monitoring, nothing. And because the lock is right next to your data, it's super fast, super low latency. Now, the main thing to watch out for, the con, is connection pooling. A long-held advisory lock can tie up a whole database connection, which can be a scarce resource. So you just have to be smart about how you use them. And that leaves us with the big question. What's the right tool for your job? Should you use a simple lock in Redis? Do you need the bulletproof safety of Zookeeper with fencing tokens? Or is the simple zero-ops approach of Postgres advisory locks good enough? Honestly, the answer depends entirely on your needs. It's a trade-off between safety, performance, and how much complexity you're willing to manage. The key is knowing these patterns exist so you never have to trust a client that says, "Don't worry, I've got the lock."